goal for this experiment is to get a steel pin to float on water. In order to do this, we have to control our forces. The sum of the forces in the y direction need to equal 0, meaning the force due to surface tension needs to equal the force due to the weight of the pin. Now, when we do this, there are very few variables we can control. When we break it down, our L's cancel out, so our lengths are irrelevant, and our densities and gravities are going to be a constant, meaning that as we work through the math to solve for our diameter, we're going to get down to the maximum diameter allowed. Now, our diameter does not have to be that large. Ours is not. Our diameter is going to be 0.58 millimeters as opposed to the 1.567 that we've calculated as the maximum allowed in order to float. In doing this experiment, the surface tension will cause the forces upward on the pin, exact opposite of the weight. This will allow us to float the pin in water, even though the density of our pin is going to be greater than the density of water.
Now here we are. To kick off our experiment, we have this cup of water here, and this needle that we are going to be testing the surface tension of this water with to see if this needle will float. Now, as you can see, the needle is in fact floating on the water. Now with the needle still floating around, you can see it in there spinning. We are going to be adding a surfactant as Dawn dish soap. I already have it here on a Q-tip. We're going to be dropping that on the water surface, seeing what happens. As you saw, I'll zoom in here for you. The needle did drop to the bottom of the cup, and that is because of the molecules in the water. They act in such a way that the surface tension decreases the way the surfactants align themselves at that air-water interface. Our last experiment will be a phenomena using parsley, the spice that's only decorative, not for flavor. I'm going to put some of that in the cup. And that parsley sits on top of the water surface because of the high surface tension of that water-air interface. Now I'm going to be adding this surfactant, dish soap as from the last experiment. Put this over here to give you guys a closer look. And here we go. Let's see what happens. These water molecules are strongly attracted together, but when this surfactant is added, the surface tension decreases and water molecules spread out, carrying the parsley with them. And that's all. That's the dog that was making noise in the last one. This is my dog Max, and he's going to show you how to shake. Shake.